Hello, I'd like to walk you through some of the ways that we describe data. That is, we have a distribution of scores out there and we want to know where do the scores center around. Those are measures of central tendency, i.e. the mean, the median, and the mode. And then we're going to talk about measures of spread, dispersion, variability, heterogeneity. These are all words for the variation in the data so that we can quickly describe that data set to someone based on the spread of the scores. So first, just if you want a single slide that's really going to be helpful to you, this particular information comes from another textbook, and it tells you that when we have nominal data, that the mode is going to be the best measure of central tendency. When we have categorical data, when we ask, for example, what was the most frequently occurring gender of the students, and at that point we could say it could be men because there were more men than there were women. So with mode, you're simply saying what is the most frequently occurring score, and this is good for nominal or categorical data such as the gender of the student. The median, on the other hand, is the best measure of central tendency under conditions where you have ordinal data. I hope you remember that with ordinal data you're thinking position or order, and the median is the middle point with ordinal data. It's a good measure of central tendency to use in that instance. The median also is an excellent measure of central tendency, or where the scores center around, when you have skewed distributions. When you have scores that are in the extreme, I hope you remember the mean is pulled to the extreme. The mean is pulled to the extreme. And in that case, the mean is not going to be a very good indicator of where the scores center around. The median is going to be the preferred measure of central tendency when you have skewed distributions and interval ratio data. Generally, when you have a normal distribution, the data is not skewed. The mean works pretty darn well as a measure of central tendency. So keep these in mind. A few other things to remember about the median, a little review. The median is the 50th percentile. The median is the middle score with position. Those kind of things I think will help you out to distinguish these. All right, when you have a normal curve, when the curve is symmetrical and it is not skewed data, you have a nice curve that looks something like this. This is the standard bell curve. And in the instance of the bell curve, it turns out that the mean, the median, or the middle of the scores, and the mode all correspond to this center point, to the same score in a distribution of scores that are normally distributed. The mean, the median, and the mode are all going to be equal in that case. So I wanted to just point that out for you. That will not be the case when you have a skewed distribution. Here we see a negatively or left skewed distribution. And the mean, remember, the score that corresponds to the mean is going to be down here. It's pulled to the extreme. If you have a couple of students who score very low on the exam, that mean is going to be pulled in this direction. The mode is the most frequently occurring score. So to identify where that is on the distribution, you simply look at frequency. You find the most frequent score corresponds to the height, the tallest point in this distribution, and you come down here and you would write, here is the score that corresponds to the mode. The median is the 50th percentile. Half of the scores are to the left and half of the scores are to the right. So by looking at the shape of the distribution, you can get an idea of where the mode is, where the median is, and where the mean is. Okay? Remember that the mean is pulled to the extreme. Now, with regard to variability, we're going to talk about 4 different measures. Your book does not mention the last one, which is the interquartile range. We're going to briefly discuss it. You already know from high school that the range is simply the difference between the highest score and the lowest score in a distribution. It's the least stable measure of variability, the range. It's only going to depend on the 2 extreme scores, so if you change one of them, it's really going to change the range. The variance is not often used, but we use variance to get the standard deviation, and the standard deviation is one of the most oft-used measures of variability or spread of data. So let me tell you what each of those are. First, I'll talk about the variance. The variance is a measure of the spread of the scores based on the squared deviation of each score from its mean. How deviant are the scores from the mean? The variance actually represents the average, okay, of the squared deviations of the scores from the mean. Sometimes it's called the mean squared, okay? And, there are different types of variance, and we're going to talk about those. But if I were you, I'd take a few minutes to reread pages 44 and 45 in your textbook to understand variance. The standard deviation, all right, is one of the best measures that we can use to get an idea of how spread out or heterogeneous the data is. The standard deviation represents the average variation or the average deviation of the scores from the mean. How far, on average, are the scores from the mean? That's the standard deviation, okay? Again, we'll talk a little bit about the interquartile range. But I want to remind everyone, we're talking here, when we're talking about measures of variability, is how homogeneous or heterogeneous a data set is. It's obvious from looking at these pictures of dogs that these are all very kind of spread out. For example, let us say that we measure the heights of these dogs. This is a very heterogeneous, this is a very variable group. This group of dogs will have a standard deviation and a variance that's higher because there's more deviation from the average, okay, than this group of dogs where everyone is fairly similar. There's little deviation, little spread. The standard deviation of the height of these dogs is going to be very low because they're all very homogeneous, okay, especially when compared to this group. So if you look at what the book says, I've pulled out here one of the tables from your book. Variance is considered a representation of the average of the squared deviation of the scores from the mean. So we're going to do this the long way. This is the definitional, conceptual, didactic way of looking at what a variance really is. So first we have the scores, which are indicated by your x values. We have the mean, which you can calculate for this set of scores, all right? And looking at this column of data, we get what's called the deviation. How far is this score from the mean? We simply subtract one from the other, and we see that this score is right at the mean, not deviant at all from the mean. This score, on the other hand, 1 minus 3 is a minus 2, is 2 below the mean, 2 below the mean. So we have the deviations here, okay, and these deviations from the mean were obtained by taking each score, and if you follow my arrow here, each score, or x value, we've subtracted it from the mean, and when we sum these up, we see that we get that the sum of these deviations from the mean is 0. Why? Because the mean, remember, is the balance point of this data, okay? So what we do to get an idea, all right, of how far these scores are from the mean is somebody figure out if we just square these deviations, we don't run into this problem of the sum of these deviations being 0. It will always, always, always be the case because of the nature, okay, of the mean. The mean is the middle point, that the deviations from the mean are always going to be 0. No matter what data set you have, this column is going to be 0. But if you square those deviations and then you sum them, you end up with something that looks like this. So 0 squared is 0, minus 2 squared is 4. You now sum these deviations and you have something that you can work with regard to figuring out how far are these scores from the mean. How far are these scores from the mean? Well, to get the average of the squared deviations of the scores from the mean, or the variance, we're going to follow these steps. We're going to calculate the mean. We're going to subtract the mean from each score to get the deviations. We saw this in the previous slide. Then what we're going to do is we're going to square each deviation, as is shown here in this column. Okay? And then what we're going to do, we're going to sum the squared deviations from the mean, okay, which is the numerator here. And we're going to divide by the number, all right, of scores minus 1. And this is going to give us something called the variance, which we're going to symbolize using, again, the Latin, not the Greek, because we're talking about the sample here. We're going to indicate this with an s squared. Okay? So, when we have to calculate the variance, all right, we're kind of interested in something that represents the average of the squared deviations from the mean. Okay? So we're going to try to get, here we got the squared deviations from the mean. All right, what's the average of those? Well, we have to divide that by something. And we can apply this formula. And this formula is what we call, this is the one that's on your yellow sheet, all right, that's labeled probably the didactic or the definitional or the conceptual formula. This really shows you what the variance is. What is the variance? Well, it represents an average. So you're summing things together and dividing by a number. The average of the squared deviations from the mean. Now, I don't know about you, going through and creating this chart and doing this calculation is a huge hassle. So you'll notice on your yellow sheet, all right, you also have what's called the calculational formula for the variance. In this case, you can simply use this output from your calculator, which all of you should be pretty adept at right now. This output from your calculator, and then you square it, plug these numbers in, use your order of operations, and this will take you half of the time, okay, as compared to this way of determining the variance, all right? So, for the sample, when I ask you to show your work in a problem, I'd like for you to take this number from your calculator, show it, plug it into this formula, this number from your calculator, plug it into the formula, plug in the number of scores here and here, right? Do this calculation, and you're going to see that the variance, all right, for the sample will come out the same whether you use the didactic or the calculational formula, okay? Now, in the olden days, we used to watch this TV show called Lost in Space, and this robot would always come up and save this young boy. It was about a family that was lost in space, and there would always be these aliens attacking them. And you can get onto these YouTube videos, and you'll see that this robot would always come up and warn this young kid, "Danger, danger, Will Robinson." And he would let them know that the aliens are coming. I'm telling you, danger, danger. You're going to have to know what the standard deviation represents. You're going to have to understand how we get to a calculation of a standard deviation for this course. So let me take a minute and walk that through for you. Now, the standard deviation is a lot like the variance. Remember that the variance represents the average of the squared deviations from the mean? Well, the standard deviation represents the average variation of the scores from the mean. It's the average variation of the scores from the mean. So we're not squaring them now. We're kind of saying, what's the average kind of spread of these scores around the mean? Well, when we take an average, you recall, all right, you want to sum things up and divide by the number of scores. But just like before, we saw the problem that the sum of the deviations is always going to be 0. So what you have to do to get a standard deviation is you have to do just like we did with the variance. We have to square things to get an idea of the magnitude of how far these scores are from the mean. But because we square it, and that was like weird, we want to get back to something that represents the average variation from the mean. Not the average variation of the squared deviations from the mean, but just the average deviation from the mean. So we're going to see in just a second. The standard deviation is simply the square root of the number that you get for the variance. I'll say it again. The standard deviation is simply the square root of the number you get for the variance. So here, all right, is we're trying to get a something when we calculate the standard deviation that represents the average variation from the mean, okay? So you would think we'd add up the deviations, we'd add up these variations from the mean and divide it by the number. No, that's always 0. That's the problem here. That's the problem for why we can't just take the average of the deviations of the scores from the mean in order to get the standard deviation. So we have to do something else. We have to calculate the variance first, okay, using all the steps I've previously described, and then you take the square root of that at the very end of the calculation. So what you're going to see here is here's the calculational formula for s squared, represents the variance. Here is the calculational formula for the standard deviation. In order to get back to the original units of measurement, when we talk about a standard deviation, we simply have to take the square root of the variance. Okay? That's explained nicely in this particular slide. If you want some review on variance and standard deviation, I'm going to ask that you take a look at this website here. It's really kind of fun. It kind of walks you through. It's built for high school students or junior high school students to try to take them through the concepts of what is a standard deviation, what does it really represent, and we see here it's illustrated by this heterogeneous group of dogs. The scores aren't the same for the heights of these dogs. There's a mean. There's some dogs that are this way, taller than the mean. There are dogs that are shorter than the mean. What is the standard deviation? What's the average, or what represents the average deviation of those scores from the mean? Okay, the last measure of variability is the interquartile range. The interquartile range, just so that you're familiar with it, divides the data up into 4 separate parts or groups. Okay, the first quartile is equivalent to the 25th percentile. It means it is going to capture the scores that are at the 25th percentile or below in the distribution. The second quartile is equivalent to the 50th percentile, okay? All right? This is equal to the score that's right in the median or the 50th percentile of the distribution. The third quartile is equivalent to the 75th percentile. The fourth quartile represents 100% of the scores, okay? And so we're going to see this, and I think there's an illustration of it right here. Here's the smallest data value. Here's the largest data value. A quarter of the scores, or a quartile of the scores, are between here and this value at quartile 1. Another 25% of the scores are here. So the second quartile represents the median, the 50th percentile, and so on. Okay? So, you can see examples of the interquartile range, which is between quartile 1 and quartile 3. There's a nice short video here in Khan Academy to explain this to you. The interquartile range kind of captures the center part of the data. It's pretty stable, all right? And you're going to read about that in places, and I just want you to know that it's out there, and it's a measure of dispersion variability, much like the standard deviation and variance. Okay? I'm going to stop here on this, and I'm going to let you know that you have an opportunity for 2 extra credit assignments. The first one we were supposed to get in class this week. I'll give you 2 points on the next exam if you get it correct. Here's the way you do it. When you're asked on an exam or your homework to show the work, and you're asked to calculate a mean, I'd like to see this formula that shows that you sum the scores and you divide by n. And in this case, you've got 4 scores. That's your n. You sum those together and you get 291. 291 divided by 4. Your calculator should check this for you, and the mean of these 4 scores should turn out to be 72.75. When asked to show your work using the calculational formula for the standard deviation, I'll remind you we're looking at the sample. You're going to use this formula. You can snag these values very quickly from your calculator for these 4 scores, okay? Calculator gives you this. Calculator gives you this. You take that and square it, you have this. And now I'd like to see that when you show your work, you actually plug in these numbers, do the math, and you're going to come up with a standard deviation that should match up to the same standard deviation that your calculator gives you. Rarely will I ask you to show your work and do all of this, but it's going to give you a couple more points on the exam if you do this correctly and turn this in either Wednesday, Thursday of next week. Then you can use your calculator to come up with the mean, all right? You can figure out using your calculator the difference between the highest and the lowest score for these distribution of scores, okay? You can calculate using your calculator the standard deviation, which on my calculator comes out as something like this, okay? You're not having to show your work in this problem. You then can go back and you can find the mode by listing all the scores and seeing that the most frequently occurring score in this distribution was 206. And you can find the position of the median by listing all scores, figuring out the position of the median by using this formula. So this is one of the extra credit assignments that you've been given. The second way that you can earn some points on this next exam is to take a minute, read through the handout that I gave you on measures of variability. Understand what is the didactic, the conceptual way of calculating the standard deviation. You need to go through all of these steps, all right? And then you need to use this long formula, all right, after you've gone through all this kind of understanding of what really is the standard deviation. You need to then take these values, okay, and plug them into this formula, all right? This is definitional. It says, hey, I have here the mean. I can figure out the deviations from the mean. The problem with the deviations from the mean is they'll always sum to 0. So I square these deviations so I get an idea of how far these guys are from the mean, all right? But because I squared them, okay, because I squared them, I need to take the square root to get back to the original units of measure and give me a number now for the standard deviation that gives me an idea of how spread out the data are. You also can use the calculational formula or your calculator. You can see here when you use the calculational formula for the standard deviation, you're taking the scores, you're squaring them, you're summing them up, okay? And remember PEMDAS, you square, all right, before you sum. So you square each of these, you sum them up, and now you can use the calculational formula. Your standard deviation in both cases should turn out the same, all right? I'd like for you to go through this exercise for potentially another 2 points on the exam. Thanks, and have a